to the club.
Right. Hi, everyone. My name is Varabuntu. Today, it's 7th of March, 8 a.m. PST. And just to let everybody know, this is a Kubeflow Spark Operator community meeting, and it is being recorded and it will be shared with the rest of the community. So with that, let's get started. I would like to first, anybody who's new to this meeting, community meeting, for Spark Operator community meeting, you can come onto the video as per the list that shows in the names and just say what you do and where you work and just a quick intro, and then we can kick off with the agenda. Right?
Hey, good morning. I can get started. My name is Luciano Rezende. I work at Apple, same team as Andrew, and I'm working with notebooks and integrating with Spark. So it's just interesting to see what you guys up to. Thanks.
Thanks, Luciano.
May I continue?
Yeah.
Hello, guys. I'm Antonis. You can call me Tony. I'm a Greek. I'm a final year CS student from University of Athens, and I'm interested in the GSOC Project 6. So I'm interested to see what you have to say.
Thanks, Tony.
Okay, nice. If I can. So I'm Xavier from France, and actually we are more end user of Spark on Kubernetes. So we have a big data platform, pretty big, around 10 petabyte, 30,000 vCPU, and okay, we are running some of the workload on Spark on Kubernetes. And the interest, yeah, and to follow up on Kubeflow and so on for future usage.
Nice. Great to hear the scale. Next.
Good morning, everyone, or hello, everyone. I'm Peter. I'm also a teammate of Andres here at Apple. I do a lot of technical user support here, doing mundane stuff like Spark tuning, and I also do a fair amount of Jupyter kernel development. Nice to meet you all.
Thank you, Peter.
Hello, my name is Z. I also work with Apple. I'm working on maps data. We use Spark to process the logs and the metrics, and happy to learn from the community. And
thank you. Welcome. Anyone else?
Yeah, hi. Hello, everyone. My name is Shekhar. I'm from Apple India office. Currently, I'm exploring the Spark operator, Spark in Notebook, and also propose the project idea, batch processing gateway integration. So, yeah.
Thanks, Shekhar. Anyone else? Looks like everyone introduced themselves, right? So good to see Yichen. Finally, he's managed to join. Right. Okay. I can kickstart the this week's community meeting. Just so that all the new folks that um, my name is Varabantu. I work for AWS, but I'm also a maintainer for Kubeflow Spark Operator. Along with, we also have Sharon Yichen, who's here, Jacob, and some of the maintainers. All of them could not attend this meeting because of the time zone issues and spread across all the time zones. So mostly our communication is within the Slack channel and through the issues and the PRs that you raise on the repos. And this meeting really helps you to bring in some new topics and or any concerning issues that you think that we need to work on so that we can prioritize and work on those kind of areas. Right. So with that, I don't have many topics this, but if you think there are any topics, just please feel free to add. I added one topic, Spark operator benchmarks. Probably we will go through that Spark operator benchmarks, and today, um, myself, Manabu, and few others at AWS ran some benchmarks, and the issue is mentioned in the agenda, as you can see here, and also the PR. PR is raised to our docs, Kubeflow docs, but I can quickly go through a bit of a summary. Maybe Manabu, I will let him to just talk a bit more about it. So yeah, and then we can open up for some of the discussion and see if you have any area that we need to improve. But the goal for this Spark operator benchmarks, there's a lot of issues around Spark operator not performing at high concurrency and large number of parts when are submitted to Spark operator, because the operator itself has to spend time to process those thousands of jobs. The scale of these jobs varies for organization to organization. There are some users who are doing small number of job submissions who won't see any difference, but there are large scale users who are submitting thousands of jobs with a span of 5 minutes, and they see some sort of a lagging where Spark operator takes to process these jobs and submit back to Kubernetes. So with that goal in mind, we thought of running some benchmarks, basically submitting a bunch of jobs, like this benchmark that we ran for 6,000 jobs. Manabo will go through in a more details, but so the idea is to submit the jobs to see how long it processes, where Spark operator can handle that, and how much CPU and memory is required for Spark operator, and what are the best practices in terms of running Spark operator for a large scale. So these are some of the goals. So I will open up, and this is running locally at the moment. As you can see, guys, this PR is still open, related to Spark benchmark here. It's under Qflow website. If you have any comments, please feel free to add that. But this is how it looks because it's running locally once it is merged. Okay, so I will let Manabu to talk a bit more about these benchmarks.
Yeah,
Scroll that.
hold on. Let's see. Yeah, so we conducted a bunch of benchmarking, like Val mentioned. Let's see. So we had our EKS cluster running. I think we had EKS 1.31, and we had some of these networking configuration. You can read a little bit more about it. And we also had the node configuration. So we had dedicated nodes just for the Spark operator, so that the Spark operator could use the entire node, as well as some other configurations, like having dedicated node for Prometheus, because Prometheus was getting overwhelmed with the amount of data that's going through it. All the details are in there, but the configuration we have here is what really comes down to when it comes to interesting facts about the characteristics of this operator. So we had about 6,000 Spark applications submitted over about 3 minutes. So the goal was to stress test really. So we didn't want to do like a steady increase or steady rate of applying these Spark applications. So we just decided to just do a stress test. And in the future, we might change this. But for this initial test, we just decided to do this way. And we used Locust to test all this. For those of you that may not know what Locust is, Locust is a web load testing framework that's often used for like testing out your web applications. But for this, it actually works well for our purposes as well. So we just decided to use that to concurrently submit about 2,000 Spark applications spread across 3 namespaces. And then we built a Grafana dashboard.
That's right.
Yep, to measure these metrics. So measures like CPU usage, memory usage, network transmits, bytes, very typical things. And we also managed or measured Spark application specific metrics like latency percentiles, submission rate, that kind of things. And then finally, we also have the Kubernetes metrics, and this is the Kubernetes API metrics. So you can see that towards the end we have a screenshot that shows you like all these metrics in the end, so we can look at that, and it'll be comes to more clear as you go through it. So the first one is that we tested with just 6,000 Spark applications with webhook enabled. Within this test configuration, we just use the very vanilla, meaning that the default configuration that comes with the Helm chart. And we run that on 36 vCPU and 72 gigabyte memory. These are all dedicated to the Spark operator pods. And we run, that test that we mentioned earlier. Oh yeah, Vara, there's an error there. So the controller threads, we actually used 10 threads, not 20.
Yeah, initial test.
Yeah, the initial test. Yeah, so it comes with the default configuration for the Spark operator. It uses 10 threads, not 20. Let's see, and then we had Spark application pods. These are spread across 200 M6A 4X nodes. And then, so these nodes come with 16 vCPUs and 64 gigabytes of memory each. And then we had one driver and 5 executor pods per application. So that means 6 pods per application. So that's about 36,000 pods for these tests. And then, like I mentioned earlier, we spread all that across 3 namespaces. So we have Spark Team A, Spark Team B, and Spark Team C namespaces. All right. So as far as observations that we saw, the largest one definitely is the CPU utilization. This operator seems to be very much limited by CPU resources available. So if you look at the graph, it might be a little difficult to see, but it's essentially just can use about like 20, 25-ish cores with just 10 Go routines. So that means, with the default configuration, this is probably as much, CPU usage that you can get out of Spark operator. And then we'll talk about, using like an increased Go routine towards like in the next section, and then we can probably increase it more. But the main, thing is that you can expect about 130 to 140 submission rates per minute. So Spark application or Spark operator can submit about 130 to 140 Spark applications per minute. Okay, and then moving on to the next section. Let's see. Oh yeah, yeah. Sorry, go back up a little bit.
Yeah.
Go up a little bit. Let's see. Yeah, then time to process jobs. This is quite a bit. As I mentioned earlier, it can only handle about 140 or 150 Spark applications, per minute. So that means if we overwhelm it with 6,000 jobs, you can do the math, right? It takes like an hour, 30 minutes, depending on how many applications you are submitting. So it can really take, a lot of time to process all these. So if you're offering like Spark application or Spark operator as a service for your organization or something like that, you really have to be, worried about these statistics here.
Yeah.
And then we also have some work queue duration, metrics reliabilities and issues. This has a max bucket of 3,000 or 300 seconds. So that means, you had to increase this to really show the actually get that meaningful metrics. So 300 seconds default value means that anything that takes more than 5 minutes is going to show up as 5 minutes. So if your Spark application processing rate is low, low, and it takes more than 5 minutes to process these, then everything above that shows up as 5 minutes. And that's obviously wrong. So we have to change that to make sure we can actually capture the correct values. But then we
And
also,
the PR has been raised and merged, right? So,
yep. So we have the PRs open. This is just for the Helm chart. The support for that is actually already available in the Spark operator binary. So we just had to map that out and then make sure it's available. And then we also saw some API server performance impacts. So we actually saw the Kubernetes API request iteration increase was significant under the high workload conditions, especially the list calls. For like a get and push, all that was not bad, but the list was definitely impacted here. This is likely not have anything to do with the Spark operator itself. It is very likely that it has more to do with the Spark application, meaning that when the driver part is trying to get the executor parts for its own, that one that you're coordinating with, then it's going to call the Spark or the Kubernetes API and do a list call to get all this information. And when there are a lot of parts in the namespace, it can affect the performance of the API server. So that's what we are showing here. And then if we set the the polling with resource version, so if you set the resource version to 0, that's what it's doing here. So in the Kubernetes API, you can actually set the resource version when you're doing a list call. You can set the resource version to 0. What that means is that you are actually saying that, hey, I actually don't need to get the data from the etcd, right? I just want some data from what you have. So meaning that you're just getting the data from the API cache, local cache. So that information could be outdated, especially in like HA configurations, but it can dramatically increase the performance. Right. So if you look at it, this graph here, you can see that there's a huge difference between the above and the one below. If you look at it,
it's a 48 milliseconds to 850 milliseconds. The huge difference, right?
Yeah. Yep, it's a huge difference. And then let's see. Oh, yeah, and then here is the just the overall metrics that we observed. You can see that we have some pod metrics. You can see that on the upper left, there is a huge increase in the maximum CPU usage, and that is the maximum you can use at 10 Go routines running at the same time.
Yeah, I mean, just a notice here, the instance that we use, C59X large, has up to 32 vCPUs. Right?
36.
36. And with controller worker set to 10, it could go up to only 25 cores. That's the key thing to notice. We were able to maximize the CPU usage in the next test by increasing that controller worker set to 20, doubling it. Go on, Muna. You're on mute.
Yeah, sorry. So the memory usage seems to be very minimum. So as you can see there, the max memory usage essentially just stays at around 3.5 gigabytes to 4 gigabytes. And it's really not limited by the available RAM at all. As for like networking transmit bytes, these are fairly small numbers. So as far as I can tell, I don't see this being a bottleneck in most circumstances.
So just to interrupt Manabu. So these Grafana dashboards, like Manabu said, we created a custom Grafana dashboard, which shows the metrics for Spark operator metrics and Kubernetes metrics and Spark application metrics. And we are trying to open source this and under Grafana umbrella. We will send a link to that so that you can easily use that if you're using Prometheus, and you can leverage that Grafana free open source dashboard.
All right. And as you can see, we have all these different metrics as well. Like Vara mentioned, we'll be open sourcing this, and it will be available for you guys to use as well. All right, so let's move on to the next test, which is essentially the same test as previously, but we are just increasing the Go routine numbers, so the threads, to 20 from 10. The main thing that you can get away from this or get out or take away from this experiment is that the the amount of jobs published or jobs processed per minute is increased by about like 10-ish compared to the one before. That's really the only change we saw. We saw that it can actually use 35 cores in use. So like we said 36 vCPUs available earlier, but there are some reservations that Kubernetes have to make sure that Kubernetes has enough, and other resources are actually used for the maintenance purposes. But yeah, otherwise the results are very similar to the the default configuration we showed earlier. You can verify that and then take a look later and let us know what you think. And then let's talk about test number 3, which is the, just has 6,000 Spark applications, and we are using 20 controller workers, and then resource version is set to 0. We see that the, all this is pretty much the same things, except that we are setting the resource version to 0, like I mentioned earlier. And then increasing API latency is virtually gone, as we expected. You can see that in the graph at the bottom, probably. And then we also saw that, about 140, 150 application processed per minute. These are very consistent with what we found in test case number 2. And finally, test number 4, we have the 6,000 applications with webhook disabled. So this is essentially the same thing as test 1. So all default configuration with Helm chart, except that webhooks were disabled. So we saw that disabling webhook reduced the job start latency by approximately 60 seconds. So it did increase. We did see some increase in performance there.
Yeah, I mean, this is leveraging pod templates. So the feature that we added recently of built-in pod templates within Spark Operator by one of our contributors. We just simply switched off that webhook while deploying the Helm chart. There's an option. And then we use node selectors, stains, and in other things as a part of the pod templates, so that and repeated the same tests. We have seen a little improvement, like Manapu said, overall. But if webhook is a requirement for a lot of our community for any other security things, and then please evaluate that. And we have written some of those guidance below that.
Yeah, so here are some key takeaways. Like I mentioned earlier, Spark Operator is definitely CPU bound with not much memory use. And, if you are hitting that limit as to, like 25, 26 vCPU cores usage, you probably want to increase that. But there is definitely a diminishing return when it comes to that. And then Kubernetes ape server latencies, you will see that if you just use that default configuration without using pod templates or the resource version restrictions, then you will see some API server latencies. But this is just for list goals. And if you're okay with having slightly outdated versions or anything like that for your pods, then setting the resource version to 0 might be a good operation decision for you.
Yeah, I think is there a scope for upstream Apache Spark to improve this area where when you're submitting thousands of jobs and the driver needs to make a call to the API to communicate with executors, and I haven't gone through the implementation yet, but just to see if it is leveraging cache rather than hitting API server more frequently. The reason being here, sometimes even if you're a Spark operator, if you give enough CPU and memory, not memory, as we see, it's more CPU bound. But if your Kubernetes API server is not good enough to scale, then you might throttle your application. So a lot of these cloud providers, like in this case, we ran Amazon EKS, and you have GKE and AKS and other Kubernetes versions. They tend to scale API servers behind the scenes automatically based on your load. So you also need to consider how the scaling is happening. But sometimes some of these self-managed Kubernetes clusters are very large, can cope with tens and thousands of nodes. In such cases, you will see completely a different set of results. So I just want to keep you in mind. It all depends upon the size of your API server and your control plane of Kubernetes. And these results might slightly vary that.
Right. And then the webhook overhead, like we mentioned in the previous tests, if performance is something that you really want to get out of, then this is an option you might want to consider. And then we saw some namespace management issues. So if you have like 6,000 Spark applications running in just one single namespace, it is going to cause some pod failures. It just says, arguments that's too long. This is due to the fact that Kubernetes adds, every single services available for within the namespace into the environment variables. So at some point, the environment variables gets too large, and that's the what you call it, the error message you are going to see when you hit that. So it's probably a better idea to either spread them across a different namespaces or just set a same TTL, so time to live, so that they just kind of get garbage corrected as they are done. Let's see. Yeah, so recommendations as far as the test results goes, deploy multiple Spark operator instances. Like we mentioned earlier, a single operator, there's definitely a limit and diminishing returns as you get more resources. It gets more expensive and may not be able to handle everything that you want to throw at with just single instance. So do consider deploying multiple Spark operator instances. And then let's see, disable webhooks. If, like we mentioned earlier, if you really want to get the best performance out of this, disable webhooks. But do consider the fact that it does need some modification to your applications, as well as there are some implications that you may not be aware of. Let's see, increase the number of workers. So you want to make sure that the operator has enough Go routines configured so that it can use all the available CPU resources. And then we also want to use the batch schedulers so that the let's see, like volcanoes, unicorns. This custom scheduler is going to help you place those pods more efficiently. I think these are discussed earlier in somewhere else, but we just wanted to putting that up in here as well.
Yeah.
Let's see. Yeah, and then Kubernetes clusters performance. This is definitely something you should be aware of and make sure you are monitoring that as part of the Spark operator operations and getting the last limits and everything. Like I mentioned, the namespace usages, don't put everything in just one namespace. It's just going to cause troubles in the past. And let's see. And then lastly, just monitor and adjust. Continuously just monitor, and then just validate your optimizations. Really, we talk about performances here, but not everything is about performances, right? There are security implementation, implications, as well as organizational requirements. So just don't follow this just for the sake of performance. You should always consider other aspects of your applications as well. Having said all that, we do publish our benchmarking kits in the Data on EKS repository as well. If you want to take a look at code and how it's done, everything is outlined there. And yeah, thank you very much. If you have any questions, we are more than happy to answer them.
Yeah, thanks, Manav. So the PR is out there, and this is the first attempt of the benchmarks, and we would love to extend and work with any of the future improvements and adopt these tests. But then, yeah, let's open up for the questions. Andre, go on.
Yeah, I think I have a few of them. I think this is great. Thank you, Manbo, for this comprehensive review. Just first of all, on the webhook side, you mentioned that disabling webhook, increasing the job submission for 50 seconds. Do you know why it is happening on the operator side? Why taking so long to mutate the jobs?
I think it just, so if you look at the webhook duration metrics, I'm not sure if exactly where it is, but if you look at the image there, I think it's just taking the webhook pods to process all these for some reason. Also, you see that because of there's like a lot of pods being requested for each of these jobs. There are other webhooks that's running on the EKS side too, right? For example, you might have like a pod identity, webhook injector and all that stuff. They may not be scaling as fast as it needs to be. So we don't know exactly why that's the case, but this is what we saw.
Yeah, I guess like because you do mutation every like on a pod level, right? Not on the
Yeah.
Spark pod level. Yeah, I think like, building Spark jobs on top of job set will definitely, I think, help you. Like if you don't really, managing the pods directly, but managing like maybe high level applications, right? But this is something maybe to consider
I
to
think there is
improve
a
performance.
proposal from Salesforce. I'm not sure if those guys are here. That's going to be our second topic. And I think so. Our current solution relies on Spark Submit, the upstream Spark Submit, and
Yeah.
then the driver takes care of the rest of the executors. But and there's a discussion around improving that performance of improving that performance of submitting through using Golang rather than using Spark Submit, Java, just to reduce
Yeah.
that JVM startup timings and so on. Right. It looks like the Salesforce team, they ran some tests and they've seen better performance. We still need to have a discussion with them and see if that is the right thing to do.
Maybe just good.
That's the issue that I listed out here in case anyone want to go through that.
Yeah, maybe just the two follow-up questions. Like I know that you rebuild the Spark operator on top of control runtime. Did you try to kind of tweak the Kube API QPS parameter, or you didn't do that? Because I know, like for example, for API operator and for training operator, I think we've done this for the run AI, and it helps sometimes to reduce this latency on API server.
Yeah, it's definitely something that we want to do for the follow-up tests. Yeah, this is we kind of wanted to get this out there with like some very simple configurations as well as getting that feedback fast, right? So like these that feedback you're providing, these are great, right? So like these QPS settings, yeah, we definitely want to tweak and see if we see any other
Yeah, makes sense.
Go on, Alan.
AWS side on this one. The EKS control plane does increase those values as we increase the scale. What we're not sure on here is how far that went. We should be able to check some of the logs from these tests or kind of check them again, but I don't know the exact value on the QPS side. We should see it increase as we scale up, and I know Renaba's cluster was up there for a while, so in theory we should have had increased from default, but I'm not sure exactly how far.
Yeah, because this in EKS case, in most of the cloud providers, they scale the control plane behind the scenes from small, medium, large based on the number of nodes and the pods. And the QPS also varies based on that. So that's probably like, step scaling. For benchmarks, it's really nice to have a static environment, not a dynamic environment. But that is something that we cannot control with the control plane because it's fully managed. But it's self-managed Kubernetes. Yes, we can control and we get an idea of actual results. Right, Shubham, you want to go next?
Yeah, so hi guys, Shubham from Salesforce here. I think someone mentioned about the Go plugin. So one of my teammates, Afzal, is working on it. I think he's working on with legal to get that out. I think that should be done soon. I had a few questions around the webhook. I think someone was asked this question earlier. Is the bottleneck where, in the case where webhook is trying to process the all the requests for job submission synchronously rather than async? And could there be optimizations on that front? Do we know how exactly is it doing it?
So from like the Spark Operator webhook side of things, I think it just uses Go's default HTTP server, right? So it should be able to just handle async for the most part.
Yeah,
I see.
I think
Okay.
there's two things. One is during our initial test, we noticed the webhook server failed. I mean, my one of the tests, and I had to increase the CPU memory. So that's like adding that overhead. And we also, I'm not sure whether you noticed, but that potentially can cause failures at large scale if you don't have the right CPU and memory assigned to webhook server. And second thing is, if you have volumes, but in this case, this benchmarks, we don't have any volumes to mount. So we're just using the some sleep job, right? So we might not be putting that uh, stress on webhook server. Like if you have PVs and PVCs, I don't know how that behaves. And even with volumes. Currently, we only have like node selectors, the labels to land that in a right node. So that goes through the webhook.
Okay, makes sense. And the other, so I'm not actively working on this, but my teammates are, and some of the information that I know is because I've been following that. So the other issue we have faced is with the operators, the controllers work queue itself, like where we saw that it was getting choked at high peaks. Like I think we reached around 300 jobs. Like these are full blown jobs, and we're running an old version of the operator. So just want to call out that.
Mm.
The question was like. I think the new version allows you by default to deploy multiple instances of the operator, um, which are still active passive, but then they listen to their own namespaces by default. And I think our initial version that we're running is more on the watching than the informers for the pods, and that's where also the bottleneck is. So, do you have any recommendations on that? Like, what approach is better? Should we think about operator sharding with rings and stuff, or just deploy multiple instances per namespace? Because our customers want sort of like an infinitely scale theoretically the operator,
Mm.
and I think that's not possible.
Yeah, it's not. I guess the two things, but anyone can chip in later on. So one is the way the current version of the Spark operator scales in two dimensions. One is using high compute machine, which is like CPU goes up to, but in this case, we are using 36V CPU. Maybe you could go up to the larger CPU where it can process more number of jobs. That's one way. And the second dimension is like deploying multiple Spark operators, like horizontally scaling and watching unique number of namespaces. But that's something. These are the two areas. But we still want to do some more tests on uh, changing the QPS itself, like this topic, bucket size and bucket QPS, to see
Right.
if that improves uh, bucket QPS and bucket size. And again, it varies
Mhm.
based on how control plane is supporting. I think that this is a third area where we want to increase and run it and see how it happens. But
Okay.
yeah,
And any thoughts on controller sharding as such? Like, do we want to go that route and consider that architecture, or do we want to stick to the operator pattern that Kubernetes default provides?
so is it the proposal that one of your colleagues submitted through this issue, right? His name, do you know what's his name? Afzal?
Afzal,
Yeah.
no, so Afzal's proposal is more on the Go plugin for the Spark
Okay.
subnet.
Okay.
But what I'm trying to say here is that it's a pretty known issue that yes, controllers can get bottlenecked just by the way they work with a single work queue. Of course, yeah, if you are running that much scale, then probably a controller or operator is not the design for you in certain cases. So that is also there. But then
Okay.
if we're really facing that bottleneck, then maybe I think some of the folks have done. I was looking at operator SDK, and
Mm-hmm.
some of the folks in the community were doing controller sharding through some fancy
Okay.
techniques. So
Right. And
yeah,
Shubham, would you mind raising an issue, mentioning this detail so that we can continue to discuss on this topic?
absolutely. Yeah, I just wanted to know like if it is even worth considering. But yeah, if
Yeah.
you feel so, I can start an issue.
Yeah, I think
Yeah.
for like Yeah, sharding. I think we did some work with Argo City on sharding as well. So and we did see significant increase in the way Argo City could handle all that. So I think it's at some point I think it is definitely something that the operator should consider. Yeah, but we should definitely open a issue and talk about it.
Okay, thanks, guys. Yeah,
Right.
sorry, and just one more question, guys. I was also researching into this. There is this now Apache Spark operator, which is also open source officially, and I think it provides Go plugin for Spark Submit by default. So, like, do we talk about that here or not? Like, are we following that progress in that particular operator?
Yeah, there's you're talking about Java Spark operator.
That's right. Yes.
Yeah, Apache Spark. Yes. Yeah. So when we proposed this, like moving this Spark operator, Google Spark operator under Kubeflow umbrella, we kind of worked with Apache Spark community to accept this one, but unfortunately that did not happen. They went ahead and choose the other one. But so the plan is, so we thought there's a lot of other customers are already using Google Spark operator. We thought of continue to maintain that, along with what Apache Spark decided to work on that. So we want to make sure this support continues on this, and with the help of all these contributors, and make it better, so that you don't have to like migrate away from this and use the Java Spark operator built by that, unless if you're missing any features, and we can still continue to work on this and make it available.
Yeah, I think Shubham,
Got it.
just one statement on this. If you think something could be improved in this Spark operator, feel free to propose an issue, right? And we can discuss it, like the goal submission, as you mentioned, right?
Right.
Yeah, definitely there are some potentials to improve it. We have some things there.
Yeah,
Cool. Thanks, guys.
we got 10 minutes left, I guess, and I want to go through.
Yeah, I would love. I know that Yichen has
Yeah.
few topics on the Spark CTL and help hook updates. Yichen, do you feel like we can follow up async on this, or it's
Yeah.
like high point thing you want to talk about? Because I really want to spend 10 minutes for this, notebooks integration if we can.
Yeah.
Yichen, any objections to discuss notebooks integration? What do you think?
Or
Yeah,
anyone has any questions?
you can first talk about the notebook integration and the home hook job and the Spark control thing. We can talk it later.
Yeah, sure. Thanks, you. We can move that to now we change that to bi-weekly, this meeting.
Yeah,
right?
It's like in 2
So
weeks.
not very far, so we can discuss these two for the next week. But yeah, let's go with the notebook thing.
Yeah, maybe just quickly, like, yes, like I know that Shekhar actually started this project for JSOC, and then I know we see a lot of kind of demand to make this Spark operator work better with notebooks and Kubernetes, right? So we have, I think, several things which we can do for the short term versus long term, right? We can build the Spark kernel like for this Spark operator. Also, we can maybe integrate the Spark operator with, our SDK. So the submission for data scientists and MLAs will be much easier, right? So I'd love to see like what do you have in mind, like Shekhar maybe, like, and what we should do initially.
So first of all, I would like to understand how currently users are leveraging Spark. Are they not at all using Notebook, or they have some other way of doing it?
Yeah, I know.
I'd like to open up anyone who want to
I think
answer it.
Luciana,
Please
since
go ahead.
Yeah, since you're still on the call here, I think maybe you could share some experience how you've done this with Enterprise Gateway, right?
Yeah, and let me step back. So I would say there are multiple ways, and depending on the way, you will see some of the limitations. So notebooks to a certain extent is just a Spark application that it's kind of like a long running that the notebook uses to submit each cells for execution. So you can run, for example, just kind of like in a client mode where you do sort of like a Spark submit, but then you have resource limitations in terms of like how many users you start scaling. The problem really happens when you need to expand for the number of users and you need to expand the utilization of the cluster into all of that. And that's when we created the gateway. The gateway allows you to basically allow the kernels to get deployed anywhere in the cluster, so you use all the resources. So the way it sort of works is you have the notebook. Notebook talks to the gateway and say, I wanted to start a notebook. That then does the application submission. The gateway is very flexible in the way that it supports, for example, let's say if you have a Spark operator, if you have different approaches, it allows and can manage that for you and then allows the notebook to connect to there. One of the recent updates that we were doing there was mostly to support the Spark operator, be able to submit CRDs, be able to do all the configuration via the CRDs. So in that way, you have your notebook. When the user comes and start, it throws a request to the gateway. The gateway creates a CRD based on a template, submits that to the Spark operator, and you get a Spark application, initialize it, and then you can connect and then execute all your workloads there. I think in the context of what we're discussing, this is probably the direction that we want to go. And then make sure that I think in the context of like Kubeflow, when notebooks are uh, being started, it allows to go through that path.
Yeah, I think
So
yeah,
you,
go ahead, Shikha.
yeah, just one thing. So Jupyter Enterprise Gateway, yeah, indeed, it is useful to submit the CRDs. So we have batch processing gateway. If you have gone through that project, that also kind of submit the application and route the application with different policies. So anyone have thought about it if we can have Python SDK for batch processing gateway, will that
So
be helpful?
the different, well, let me, so what the gateway will do the management of the life cycle, but Jupyter requires a specific protocol for communication, which is then not supported by that gateway. So we actually have done some integration where we can use the gateway for the life cycle, but then start or connect to a Jupyter gateway for the communication. The problem is mostly after you start the application for the communication, Jupyter uses the protocol um, to talk and execute all of the cells, and that is not supported on the Spark gateway. The Spark gateway mainly could help with the life cycle, but it's not uh, for other for after the life cycle or the application is started.
Yeah, it's
Uh,
basically scalar, right? You know, you submit something to the pool and then it will distribute it, right, across different clusters, right? Um,
yeah,
so
it basically it's sort of like when you say start this application, it knows where to start, and that's all. Because it's uh, aimed for batch application, that's to a certain extent all it needs, because the application then runs into the end. For long-running applications as Jupyter, where you need to communicate, you need to establish connection to that application, and you need to submit that is not supported there. So that's why you will need at least both if you wanted to support that way. Yeah. The question
Okay.
is really more like when you have the batch gateway, what are the kind of like features that you are using from that one in terms of the life cycle, to validate if that would be a necessary integration point or not. I think in the past I have done both with integration through the gateway or without, and both are acceptable or work, I would say.
Okay, yeah, thanks for sharing. I will explore more. I still have few doubts, but I will explore at my end first.
And feel free. I mean, we can have a Slack or a conversation around any particular areas you wanted to dive into. Just reach out, let me know, and we can chat, or we can schedule another
Yeah, I
meeting
think
with the community if we wanted to maybe present or do something more deeper.
Yeah, I think what would be really helpful, I think, Luciano, like maybe you already shared with Shekar like your presentations when you talk about, the enterprise gateway, right? And
Yeah.
how those kernels could be orchestrated. I think like we still need to some sort of gateway to orchestrate those kernels, right? And to talk to via like the ZMQ channels, right?
Yes. So
Mhm.
if you don't have a gateway, the
Mhm.
only thing that Jupyter supports, like natively, is in process kernels. So
Yeah.
you will not be able to go the extra hop, and then you will have the limitation of the resources on that pod or on that machine.
Yeah, and we couldn't, we couldn't just create a CRD via, like the Python client and then using Spark Connect to connect from Jupyter, from Notebook to this kernel, right? Because this is not like, I think you cannot just connect to the Spark application CRD directly, right?
Correct.
Hmm.
And so even if you could, then it doesn't support the Jupyter protocol, the ZMQs, and all of
Yeah, the
that.
kernel shut down, right? And the other heartbeat channels, right, that you require.
Exactly.
Yeah, I think understanding this will be helpful. I think because like the question, do we need to have dependent on a gateway, or we can, it's because what Jupyter needs is just a connection file, right? And connecting to this kernel so it can talk to this remote Spark application, right? The Spark cluster.
Say that last part again.
Yeah, I mean, like the Jupyter just in the connection file, right? Which allows the notebook connected to the remote Spark, the remote kernel, right? And then
No, the notebook doesn't know how to go and connect remotely to a certain extent.
oh, then yeah. I think then they also has a certain set of APIs, right? It executes from Jupyter server, right, to shut down the kernels as well, right? So those REST.
Even for execution and all of that, yes, you will need the gateway does the bridge to go remotely.
Yeah.
That makes sense.
I think we're up the time at 9 o'clock. Just wondering, Shikha, did you share that doc with the community, the proposal? Maybe you can add it to the meeting notes and maybe worth collaborating on that doc and idea with the rest of the folks.
Sure.
Yeah,
I added the issue thread, but I will share the idea page.
all right.
Yeah, I think Shikari, you just need to start a Google Doc and start to summarize some ideas there. And then we can maybe review this with the community and, provide async, feedback, right? Even before GSOC started, right? Because it's a big project,
Yeah.
right? So
Got it. Yep, sure. I will create some Google Doc, the draft at least, and share.
Yeah. All right. Thank you very much. And I know Xavier left, and it looks like they're running on a really good scale, and probably we can ask him to talk about it next in biweekly call, how they scale to 20,000 vCPUs. But I'll send a message in the channel. But thank you very much for everyone for joining this call, and have a good rest of the day. Thank
Thank
you.
you.
Bye.
Thank you, guys. Bye.